Hey everybody, my name is Melisha McGregor, and today I'll be talking to you about making VR more interesting with JavaScript and Brain.js. So I'm a developer advocate at Conducto, where we make CI/CD tools, and if you want, you can follow me on Twitter at FlippedCoding. So to get started, I'll give you a background on VR. Then we'll actually make a small VR app. Then we'll go over a little bit of background on machine learning, mainly neural networks. And then we'll actually add the machine learning code to the VR app. Then we'll go over a few other considerations when you're working with a VR application. And then we'll just go through some key takeaways. So just to get started with a little background on VR, it's a relatively new area of tech just because the hardware has been more recently created. But the applications for virtual reality span across all kinds of industries, from training medical students to video games to different forms of entertainment. And so this leads to a different career path that developers can take. It doesn't matter if you know C, C#, or JavaScript, you can find a place for you in VR. And then as this hardware starts to improve, you'll notice that virtual reality is gaining more momentum as something that companies are looking to invest in. So that's where we get a lot of the different career opportunities. But this is the fun part. So we're going to go through a live demo of how to make a VR app. Okay, so one thing that might be surprising is that you just start with an HTML file. This is the A-Frame library, so all you have to do is import the code here, just in a script file like anything else. And we also import another package that gives us access to some pre-made environments, because when you're working with a VR application, you need different assets in the world that you create. And those take a lot of time and different skill sets. So when you can take advantage of a pre-made package, it's okay to do that. And then we have a few other JavaScript files that we'll talk about a little bit later. But just so you know how a VR application works, it's just like a web application, but with different kinds of tags. So you'll see we're just inside the body, but A-Frame uses these different A tags. So when you're working on a VR application, you'll have a scene. And basically what this is everything that is in your VR world. But the first thing you do in a scene is import all of the assets that you want to use. So in this case, we have a few JPEGs that we're going to make into textures for the different objects we put in the world. And I did have music for this game, but once I realized this talk was going to be recorded, I don't think you want to hear that playing over and over again. But if you wanted to include music, you just use the audio tag like you would in any other JavaScript project. So we have our assets. That means it's time to start putting objects into the VR world. And the first thing we're going to put in there is just a box, just a regular box. And what makes this one kind of special is that if you see here, the source is actually the same as this wooden texture asset. That means that this block is going to look like a piece of wood. And this attribute is the height of the object. So in A-Frame, you can set different attributes on these A tags, and they determine how the shape is built inside of the world. So in this case, our box is going to have a height of 3 meters because A-Frame measures everything in meters. And then it's rotated a little bit around the Y and the Z axis, just to show you something different in the world. And here you'll see the position. This one is really important because this is exactly where the object is going to be in the world. So this means that it's going to be 37 meters in the X direction. It's going to be 1 meter off of the ground, and then it's going to be 37 meters in the Z direction behind us. So that's how the positioning works with A-frame. And another attribute is this animation position. Basically what this does, it lets you customize animations on objects. So what we're doing here is taking the property that we want to animate for this block, and we're saying we want to change the Y position to 2.2 meters every 2 seconds. So that means this block will just float up and down between 1 meter and 2.2 meters. And then the last thing here for attributes is this custom attribute. So this is one that we'll talk about as soon as we're done in this file. And if you'll notice, there are some just primitive shapes here. So you can use boxes, spheres, cylinders. They're all built into A-frame. But down here we have something just a little bit different. This is a plane, and all that is just, it's just a plane. It's like having a sheet of paper that you can make magically float in your world. And what we've done with this plane is just write down a few of the things that we want the user to find in the game that we're making. And to do that, we use the base A-frame tag, which is A entity, and you can set which kind of primitive shape it should be with an attribute. So in this case, we just wanted text because it's a list of items that the player needs to find in the game. And it's right at the beginning where they can see it, so they don't need to walk around to find it. Then down here, we get to another entity which has the environment, and that is what really makes the layout for your world. So that library we imported in the beginning, it's responsible for building a world based on these different attributes, which you'll get to see in a few seconds. But the last thing that I want to show you before we get into the game is probably the most important part of a VR application, and that's the camera. So where you position your camera changes the entire gameplay for a user. And that could be you put the camera behind them so that they can see themselves walk around. You can make it into first person view so that it looks like you're just looking around in the game, or you can do any kind of camera positioning that makes sense for what you're making. But what we have here is just a camera that's slightly behind the user so it looks like a first person view. And we've added just a little ring to the center of the camera so that as the user moves around, they can determine what they're looking at. So now let's just go ahead and run this app. So it should be running. It takes a little while for A-frame to load sometimes, but it's a really good library to get started with. Now you see, this is the environment that we imported from that library, and we have our list of things. We can look around, walk around, and maybe find something. I'm not sure exactly where it is right. Oh, I think we found some. Hey, so we found this object, and when you click on it, that sends it back to the starting position because you're collecting these. So the way that that works is in this found item. This is that custom attribute that we briefly mentioned earlier. And whenever you want to make a specific action for a VR object, this is how you do it in A-frame. So whenever you click on one of the objects you're looking for in the game, it goes to a specific position back at the starting point, and that's it. So back to the presentation. Now that you have seen the VR app, we'll talk a little bit about machine learning. So neural networks are a form of machine learning algorithm, and they're just used to make predictions. So a neural network is made of layers of nodes because it's supposed to try to represent what the brain is like. And basically you give it a set of inputs, you assign some weighted values to it to highlight the importance of each input, and then the neural network goes and makes different connections and assumptions and gives you an output. So you've probably heard of deep learning before, and all this is just a neural network with multiple nodes. So if you have 2 nodes in your neural network, you're doing deep learning already. Then a little bit about the library that we'll be using, which is Brain.js. And I'm sure you've heard of TensorFlow, but there's a few reasons that I chose Brain.js over TensorFlow. First, it's a lot easier to use. I'm not sure if you looked at their documentation, but you have to learn a lot of new terminology and a lot of new things when you're using TensorFlow, where with Brain.js, if you know how to work with objects and arrays, it's really easy to get started. Then with Brain, you also don't need as much background in machine learning. As long as you have your data and you know which algorithm you want to use, you don't have to know about the math or anything else behind it. You just have to know which methods to call. And then the tutorials for Brain.js are really straight to the point and easy to follow. So if you go through their tutorials, you'll find out you have a few really cool, useful projects at the end. And to get into a machine learning project, there are a few things you need to do when you're choosing features or those inputs for each of the nodes. You have to ask what will add the most value for a user. So that means, is it something that's going to make their experience better, or is it something missing that they've been asking for? You just want to make sure that whatever features you choose are going to lead to a prediction that adds value for the user. And then ask, how do you get the information you need from a user? Do you ask them for it? Do you have them fill out surveys? Do you data mine them while they're using their web browser? How are you going to get the information you need to get those features? And then this is a really important question you should ask in the beginning. What are you trying to predict with all of the information you get from a user? So that's the point of the machine learning problem, is you're trying to make a prediction based on previous information. And then one that we probably run into a lot with just JavaScript and web apps in general is, will the user actually care if we make this kind of update? That kind of goes back to what adds the most value for a user, because even if it does add value, if they don't care, then you might want to consider if it's worth all of the work and effort to build this model to make predictions for that. So make sure that any changes you make or any predictions you're trying to make are things that a user will care about when you apply them. Now we get to go back to the fun part and do some more coding, and we'll add machine learning to this app. So back in the HTML file, I wanted to show you a property on one of these objects called cursor listen. So whenever we find this box, this function will get triggered. So cursor listener basically just calls a function on the back end to get a new predicted position for all of the remaining objects. And what's happening here is that it imports this user model. And what it gets called, it goes to this backend API and it sends back the user's X, Y, and Z position, how many steps they've taken, and whether they found an item or not. And what that does for us is on the back end, we get to make our machine learning app. So if you're familiar with Node.js at all, this is just an Express app. So we import all of our libraries and packages. We set up an Express app and do some regular use stuff. But down here is where we get into the machine learning. So this is our initial training data. And basically, these are values that we've gotten from users over time. Like this is their current position right here, and whether they found the item or not, which would be the box, and how many steps they've taken in the game so far. So as you see, this is just an array of objects for our data. That's all. Then we have to have our initial training data output. So based on these inputs, we're trying to predict how likely a person is to finish the game. And usually when they've taken more steps, they haven't found an item, and they're really far away from the initial position, they have a lower likelihood of finishing the game, which you can see with this array of objects. So we have our initial input data, we have our initial output data. So we put them together into a single object that we'll use in the Brain.js library. So this training set is just a combination of our input and output arrays. Now that we have all the training data, this is probably one of the best parts, is building the model. So with Brain.js, it's super easy to build a neural network. This is it. This is the one line of code that it takes to make a neural network in practice. And all this is, it just has 3 hidden layers, which is how you add a little bit more complexity to some of the connections that the neural network makes as it's trying to get a prediction based off of the features you chose. So we have our model here. And then this is definitely the best part. You get to train the model with the data that you have. And all it takes is one method call. So we made the model up here, and you train it just by calling the train method and passing it the training data set. That's all. We have trained a neural network to make predictions of whether a user will finish the game or not based on how they've been moving around so far. So all we've done here is when Brain.js runs the train method, it collects statistics around how many iterations it took to get the final value and how the error rate decreases with those iterations. And then we just do a quick run to see if the model works. That's all this is here. So we trained it, we got our statistics on how well the model trained, and then we tested it. So now we know that this model is ready for user play. So we've set up just a simple backend API, and all it does is gets the data from the user, which if you remember, that happens right here. So we just get the position of the objects, and then we take the position of everything and move it around based on the likelihood of a user to finish the game or not. So if the user is more likely to finish the game, we'll move the objects further away to keep them playing longer. And if they're less likely to finish the game, we try to move the objects closer to them so they'll find one and keep playing and finish it. Then at the very end of this call, we just send the new position back to the items that are still on the playing field, and they'll move around accordingly. And that's all for the machine learning part. So hopefully you see that machine learning doesn't have to be really hard or really complicated. It just depends on what you're trying to do and which libraries you need to use. So now that you've seen the VR app in action and you've seen how machine learning integration works, there's a few other considerations. First off is the overall user experience. Everything you design for a virtual reality world should have the user experience in mind because they're being submersed in a completely different environment. You don't want them to feel lost or like they don't know what they're doing because then they'll abandon your app completely. And another thing is that you want to make sure you're using data ethically, especially when it comes to machine learning projects. You don't want to take people's personal data and do just unethical things with it, like sell it or use it to try to manipulate them into buying things. So make sure that all of the data you collect for users is being used ethically. And then this is a question that comes up a lot in machine learning is what's the best algorithm? Well, there really isn't a best algorithm overall. It depends on your application. So for example, with this, we were just trying to predict whether a user will finish a game or not. That could have been done with something like a multivariate regression algorithm or any number of other algorithms. It's just what feels better for your data, what gives you faster results, and what gives you the most accurate results. Those are the metrics you should use when you're trying to pick a machine learning algorithm. And then as much as I love JavaScript and Brain.js, when you get into the bigger machine learning problems, you'll definitely want to switch to Python just because they have a lot of different libraries for things like natural language processing and image processing and just all of the bigger machine learning problems. So if you want to do work with millions of data points, Python is probably gonna handle it better than JavaScript will. And so we wanna wrap up with some key takeaways. It's really important that you try to combine multiple areas of tech. This is where you get to have fun and be creative and make new things that nobody's ever seen before. So don't be afraid to combine multiple areas of tech that sound difficult because that might not be as hard as you think. And then always remember the ethics surrounding data. It's so important that we keep our data secure and that we make sure nobody's using it inappropriately because I'm sure you've heard in the news about data breaches or people using personal information to open credit cards or buy things. So you really want to make sure that all of your data is always secure and being used ethically. And of course, just try new things. It's okay if you don't understand it at first or if it doesn't make much sense, but the point is to just try it. With JavaScript, we can do basically anything from web apps to robots to machine learning. So don't be afraid to take your skills and just try new things. And try to learn something that you're interested in and it solves a problem you have. So with this VR game that I made, I wanted a really easy game to play, but not too easy. So the machine learning really adds that extra layer of complexity that I was personally looking for. And when you start to combine your interests with some of your problems, you get to make really cool products. And of course, it's better because everything is in JavaScript. So this is all I have to share with you today. I really hope that you liked it and you learned something. And if you have any questions or you're interested in more of the things I'm doing, remember to follow me on Twitter at Flipped Coding. So thank you for your time.